Yo, what up guys? Welcome back to my programming series. This is the second part of the series where we go pretty much in depth in programming here. In this video, we're going to be covering pointers, and for the next two videos, I think, because pointers is what distinguishes C++ and C from a lot of other languages that don't use pointers, and it's a really amazing thing that I only started to appreciate after my data structures course. So I've wrote about 100 lines of code here. We're going to go through all of it, every single line, and I'm going to walk you through pointers, and we're just going to talk in this video pass by value and pass by reference on pointers and what they are really. So I have a function called testing PTR in our main, and I just make a call to it. So basically all the magic's in this function. Before you get to this function, I have the prototypes up here. We have pointer by ref, pointer by value, and testing PTR. This is where we're doing our testing. And then up here, which I'll talk about later. So in our testing PTR, we create 4 integers, starting from A all the way to D. A with 0, B1, C2, D3. These could be any numbers. I just want small numbers. On line 29 through 32, we create 4 pointers of type int. So this is a way to word it. I just want you guys to be comfortable with that kind of wording. These aren't integers, these are pointers of type int. Really important distinction there. And we make 4 of them. Now I have comments here kind of explaining, but this is setting the first pointer, integer pointer, to 0. Null pointer is a key word in C++, which is an alias for 0. Null is a preprocessor alias for 0. So I actually created one up here called REAPOFF. Okay, you do hashtag define, and what that is it's a preprocessor alias for whatever you put after the name. So I made 0. So instead of writing 0, I can type REAPOFF. When it gets compiled, it just gets converted to 0. It can change the source code here, but it doesn't change the fact that REAPOFF is the same thing as 0. It's an alias. And so if we go back to line 29 through 31, these 3 lines, we set all of these pointers of type int to 0, basically. That's another way of saying, hey, this pointer, I'm initializing it, but I don't know where it's going to point to yet. So on line 32, we create the 4th integer pointer, and we set it equal to the reference of D. So you can't do something like this, because a pointer doesn't understand. It doesn't know what an integer is. All it knows how big an integer is. And so we can do something like this. Now, what does that mean? What's ampersand D? So I'm basically saying, hey, there's an integer called D somewhere in this scope. This is in our scope. And then I'm saying, set me equal to its address, its memory location. It's very important. Pointers only work with memory locations. Does not know the value of D. You can get the value of D, which we'll look at later with this. But let's just appreciate that for now. By the way, on line 29 through 32, I've changed the star around. This is declaring a pointer type. And I put the star in all these funky ways. I'm showing you, hey, it doesn't matter what you do. The compiler recognizes that these are all pointers. So now that I clean that up, it looks a lot better. Let's go down here. We can basically create pointers to strings. So string is a class. I'm creating a pointer to a string. Basically, I would have to have some variable, some string variable. And you can even do a pointer to a string iterator. So this is something we won't cover. It's a little complicated because a iterator itself is kind of a pointer. Not necessarily, but it is using internally pointers and stuff. I'm just showing you pointers to anything. Okay, so on line 40 to 42, we set pointer 1 and 2 and 3 equal to the aliases of the 3 to the variables that we declared up here. And for the 4th one, we did it up here, so I'm not going to redo it down here. We already initialized it up here. Now, all we're doing is have this output saying this is what the memory locations of the pointers are, and the value that's stored in that memory location. So this is how you print the memory location. So you just print a pointer type. So remember int, that's why I called it int pointer. So we don't confuse these with integers. These are pointer types. So when you just print a pointer using cout, and it prints out a memory location. Over here, I have the star before the variable. This is exactly why I don't like this. Because when you dereference a pointer, it must be next before the variable. So anyways, we're going to print all of that. And then we call pointer by value, this function I made. And we pass pointer 1 and 2 as arguments. And we do for 3 and 4. And then we wait until my keyboard press. And then we display the value, pass by value, what it did. And then pointer by reference. And then we do the same thing. Now let's just take a look at these functions. Here's our prototypes. So let's just take a look at our functions here. Here's the prototypes. This is why another reason I like the pointer next to the type and not the variable name. Because if we do pointer by reference, we're going to have this mess here. This is perfectly valid and it's horrible to read. I don't even know what's going on, right? So best way to do that, put a space right there. Pointer type, address of this variable. That's the best way to do it in my opinion. So in these prototypes, if you want to add variable names, you could. For example, like that, but you don't have to. Anyways, in pointer by value, we don't pass it by reference. And basically, I just set change me equal to the pointer, the second argument, which is pointer 2. And then pointer by reference, you passed changed me by reference, and then we set it equal to pointer 2. It's the same exact thing as pointer by value, except this argument is by reference. That's it. And we'll just see what happens. So let's go ahead and run it. All right, guys, so here we are printing information about the int pointers, this stuff right here, okay? Remember, pointers contain memory addresses. When we dereference those memory addresses, which I show you right here, put the star before the variable name, that actually gets the value at that memory location. And it only knows how to do that is if you specify with the right type, okay? So we are setting all of these pointers to aliases of the same type, integer. They're all integer. One is a pointer of integers, and one is just the actual literal variable of type int. So in pointer 1, 2, 3, 4, these are the memory locations, okay? And I dereference them, and I give you the values. So that's correct. If we look up here, this is our original 0, 1, 2, 3. We're not calling A, B, C, or D down here. We're calling the pointers, and we'll talk about that more in a little bit. I'm gonna press enter. So now we called pass by value. Here are the memory locations, and as you can see, they are exactly the same. So in pass by value, what's going on? Well, in pass by value, in pointer by value, the function, we don't pass by reference, right? So we should know at this point that when you pass by value, you create copies. So in this function, when I call this function, I create two integer pointer types, and whatever was passed in that memory location, this becomes another pointer to that memory location temporarily. And then I set that new copy, that memory location, to whatever pointer to. So technically it worked, but then once we exit this function, the scope closes, change me gets deleted, and the original pointer, it never got changed. So it's doing effects that we don't want. If I press enter again, pass by reference, as you can see, pointer 2, which is DC at the end, okay, it became pointer 1. And same thing over here, pointer 4, which has C4, as you can see at the end here, it became pointer 3. So the memory locations became the same. So now we have, after the pointer by reference function, okay, which is passed by reference, we have changed these pointer memory locations, okay? And see, the values changed. So now we have two pointers that point to the same memory location. You see that? So why is this useful? To really sum it up here, guys, we got the values and the memory locations of A, B, C, and D, right? These are our variables. We didn't need to know the names of these variables. I just want you to appreciate that. Just let me say that one more time, because this took me 2 years to fully appreciate. You don't need to know the variable names of these pointers. You just need to know the memory location. And when you do that, you just set it equal, right? So we just do $d. I can now pass this pointer into a function, and it knows about A, B, C, and D. Exactly. Not like a copy or anything. It knows exactly what I'm talking about. It is the memory location. It's not a copy of the memory location. It's pointing to the memory location. There is no trickery here. This is amazing stuff. Now we'll talk about in our last video with pointers, when we talk about dynamic memory, once this function closes, so we're back in int main, and then we get to std get car, which was here, these pointers get deleted because we didn't create new memory. So we don't like leak any memory or anything like that. We're going to talk about that later, but I just want you guys to appreciate that we didn't need to know A, B, C, or D, the actual integer variables. We just had pointers to them, and we changed them and everything about them. I hope I really cleared things up in this video. If you have any questions, you can always feel free to leave it in the comments. If you are new to this series and you want more refresher, maybe this was too much, this is my intermediate series. I made a 8-part video series for my basic programming series, which would prepare you immensely for this series. So if you haven't watched it, definitely go back and watch that series. A link is in the description. And thank you very much for watching.